Hello, this is a tutorial for creating a blockchain for students. First, let me go to YouTube video clip to help you understand the concept of blockchain. Okay, this is a good video clip for you. You can find this from easily from the YouTube. So let me play it for you.
Blockchains are incredibly popular nowadays. But what is a blockchain? How do they work? What problems do they solve? And how can they be used? Like the name indicates, a blockchain is a chain of blocks that contains information. This technique was originally described in 1991 by a group of researchers and was originally intended to timestamp digital documents so that it's not possible to backdate them or to tamper with them, almost like a notary. However, it went by mostly unused until it was adapted by Satoshi Nakamoto in 2009 to create the digital cryptocurrency Bitcoin. Now, a blockchain is a distributed ledger that is completely open to anyone. They have an interesting property. Once some data has been recorded inside a blockchain, it becomes very difficult to change it. So how does that work? Well, let's take a closer look at a block. Each block contains some data, the hash of the block, and the hash of the previous block. The data that is stored inside a block depends on the type of blockchain. The Bitcoin blockchain, for example, stores the details about a transaction in here, such as the sender, receiver, and the amount of coins. A block also has a hash. You can compare a hash to a fingerprint. It identifies a block and all of its contents, and it's always unique, just as a fingerprint. Once a block is created, its hash is being calculated. Changing something inside the block will cause the hash to change. So in other words, hashes are very useful when you want to detect changes to blocks. If the fingerprint of a block changes, it no longer is the same block. The third element inside each block is the hash of the previous block. And this effectively creates a chain of blocks, and it's this technique that makes a blockchain so secure. Let's take an example. Here we have a chain of 3 blocks. As you can see, each block has a hash and the hash of the previous block. So block number 3 points to block number 2, and number 2 points to number 1. Now the first block is a bit special. It cannot point to previous blocks because, well, it's the first one. We call this block the genesis block. Now, let's say that you tamper with the second block. This causes the hash of the block to change as well. In turn, that will make block 3 and all following blocks invalid because they no longer store a valid hash of the previous block. So changing a single block will make all following blocks invalid. But using hashes is not enough to prevent tampering. Computers these days are very fast and can calculate hundreds of thousands of hashes per second. You can effectively tamper with a block and recalculate all the hashes of other blocks to make your blockchain valid again. So to mitigate this, blockchains have something that is called proof of work. It's a mechanism that slows down the creation of new blocks. In Bitcoin's case, it takes about 10 minutes to calculate the required proof of work and add a new block to the chain. This mechanism makes it very hard to tamper with the blocks because if you tamper with one block, you'll need to recalculate the proof of work for all the following blocks. So the security of a blockchain comes from its creative use of hashing and the proof of work mechanism. But there is one more way that blockchains secure themselves, and that is by being distributed. Instead of using a central entity to manage the chain, blockchains use a peer-to-peer network and everyone is allowed to join. When someone joins this network, he gets a full copy of the blockchain. The node can use this to verify that everything is still in order. Now, let's see what happens when someone creates a new block. That block is sent to everyone on the network. Each node then verifies the block to make sure that it hasn't been tampered with. And if everything checks out, each node adds this block to their own blockchain. All the nodes in this network create consensus. They agree about what blocks are valid and which aren't. Blocks that are tampered with will be rejected by other nodes in the network. So to successfully tamper with a blockchain, you'll need to tamper with all the blocks on the chain, redo the proof of work for each block, and take control of more than 50% of the peer-to-peer network. Only then will your tampered block become accepted by everyone else. So this is almost impossible to do.
And blockchains. So just remember that each block has three things in it: data, hash, and hash of the previous block. So if you change the data, the hash changes, and the block will be invalid. That's how the blockchain works. So let me stop screen sharing. And for so I really like you to have some method that you can create block and change your data and have the validity test. So for that, you can use many different software and codings, but I found that Python is very useful free software. So let me show you how you can download Python. So you can go to this Python. Okay, so you can.
In this course, you're going to learn everything you need to get started with Python. Just be aware that I've designed this course for beginners, so if you have some programming experience, check out my other Python course for developers. You can see the link on the top right corner of this video. So, Python is the world's fastest growing and most popular programming language, not just amongst software developers, but also amongst mathematicians, data analysts, scientists, accountants, network engineers, and even kids. In fact, it's the ideal programming language to learn first. But what makes Python so special? Here are 6 reasons. With Python, you can solve complex problems in less time with fewer lines of code than many other languages. That's why huge companies like Google, Spotify, Dropbox, and Facebook have embraced this beautiful and powerful language. Here's an example. Let's say we want to extract the first 3 characters of the text "hello world." This is the code we would have to write in C#. This is how we would do this in JavaScript. And here's how we would do it in Python. See how clean and simple the language is? Alright, now we're ready to download and install Python. The first thing I want you to do is to open up your browser and head over to python.org. On this page, under the downloads, you can see the latest version of Python. Currently, the latest version is 3.7. Chances are in the future, when you're watching this video, there's a newer version available. Don't worry, all the materials in this course will continue to apply with the future versions of Python. So go ahead and download Python, and then run it. If you're on Windows, you're going to see this checkbox here, Add Python to Path. This is very important. Make sure to take it, otherwise you're not going to be able to follow the course. So now go ahead and install it.
Hi. So let me show you how you can create a block and blockchains and do the validity test. I got great help from great computer science department graduate student Junhee, and he sent me the coding for Python program and also the some other files. So you can check if you go to my teaching here on Spring 9, and I have blockchain here, and this is the files that I got from Junhee. And if you look at these directories here, we have you're not going to use this, don't worry about it. When you just unzip, you will have these on your computer, but you don't have to use this. But the block directory has so first it has only one block, which is Genesis. If you double click this, you can see this is Genesis block, and this is the hash of the Genesis block. Okay, and in your data directory, you have one data file, data1 text, and it says my name is Prof. Hoon and I've sent you $100. Okay, so this is the data. Okay, and blockchain. This is a Python file with coding. So you click right button of your mouse and edit with. Ideally, this is I believe this is Python's editor. So if you see this coding here, it looks pretty complicated, but you don't have to worry about it. The basic idea is you're using Python language to create a blockchain here, okay, and hash here. You're creating your hash, and this is your you're creating your blocks and your okay. You're creating your block and your hash. This is your hash, and here you have your validity test. Okay, so if your blockchain is varied, then you get the message of varied here, and I have my name here, Prof. Hoon, just to show that I am doing something to this file. And if your blockchain is invalid, then you have here invalid message. Okay, so this is how it works. So let me close it. And this main file is Python execution file. And if you click right button and again edit with IDLE, you can see that it has some coding showing always print this menu here on your screen, Python screen, and what does those command 1, 2, 3 do for you. For example, for one, you basically you are doing for one you are creating a block. Okay, here file name add block. Okay, and menu number 2. Check the validity of your blockchains, and 3 is just clear, chain clear. But we are not going to use menu 3. We will use just 1 and 2. Okay, so that's, and to start, you double click main file, then you will have this dark screen here. Okay, and it says it shows a menu as the coding has. Okay, so then you have 3 menus. So you are going to use first to create block, type 1, enter. Then it will ask you what data file you want to use. You use data1 txt and enter. Then it will show that your another block is created with this hash. So don't close it, just minimize it and go to blocks. Then you will see there is one block created here. If you double click this, you'll understand that it has 3 things, right? Data, okay, and this is previous hash of the previous block, ending with 6C, right? So we can go to Genesis block and see this is the same hash, 6C. Okay, so block 1 has its own hash here. Okay, so 3 things again: data, hash of the previous block, and the hash of the block. So now we'll do the validity test. Go down here and click. Oops, this is okay. We are going to now use command number 2 to check the validity of blockchain 1 and 2, or Genesis and block 1. It says block 1 is valid, Prof. Hoon, because it has the same hash of the previous block. Okay. Now we are going to don't close it. We are going to go to block 1. Okay, and we're going to change the data here. Let's say to 500. Okay, I have sent you only $100, but I have changed my data to manipulate. So my new data says I have sent you $500 instead of $100. This is wrong, right? So I'm going to save it, and close it, and go to here. Don't close it. And now I'm going to use command number 2 to check the validity, and I should get not this time invalid. So I have this invalid message because now my blocked the data in the block 1 has been changed. So if you go to block 1, you'll see this is wrong. So that's why I got invalid message. Okay, so this is invalid. So why don't you try this simple exercise and see if you can understand the basic concept of blockchain. Thank you. Good luck.